Hello everybody, this is the notes for Algebra 2 Trig, section 3.4, systems of linear inequalities. So we have talked for a good week or so about a system of equations, how to solve them, graphing, substitution, elimination. The last section that we did was 3.3, that was just graphing the linear inequalities, graphing the line and then shading on one side or the other. So it's kind of a combination of things. We're not really going to be solving a system of linear inequalities. What it does is gives us a solution region. Okay, it's a space where answers can be. So we're talking about inequalities. So there's going to be a lot of answers, an infinite number of answers. They're just located in a certain space. All right. So a system of linear inequalities. It's a collection of linear inequalities in the same variables. So x's and y's, a's and b's, really doesn't matter. The solution, like I just said, it's an ordered pair that satisfies each of the inequalities in the system. So we're looking at a whole bunch of them, a whole bunch of ordered pairs. Graphing is the way to solve this system. You're just showing the region of solutions. So just to give you an idea of what we're looking at. All right, I have graphed on here a couple of things. Well, here's one linear inequality, okay? You can see the equation off to the left of the screen that d is y less than or equal to 3x plus 1. So graphed it, it's a linear inequality, okay? The idea of a system of linear inequalities is now you've got a couple of equations. So I'm going to graph the y greater than negative 2x plus 5 also. And what we have is really just a bunch of points where these two regions are overlapping. This is where our solution is, okay? The solution to a system is the set of points that satisfy all of the equations or all of the inequalities. And so where these two shadings are overlapping, that's where the solution region is. You've got below this line, you've got above this dashed line here. So anything that's below this one and above this one, this is your answer region. All right. Some of these systems, actually a lot of these systems, have got multiple equations. So I'm going to throw on there y greater than or equal to 0, x greater than or equal to 0. All right. So now our solution region is where all of these things are overlapping. Okay. So we don't have this stuff anymore. We got to be greater than 0. We got to be above this dashed line. We got to be below this solid line. So it's all of this space here, okay, where all of these shadings overlap. That's your solution region. All right. So to graph a system, you just graph each line one at a time. So let's just do that. First one, x values greater than or equal to 0. That's really a vertical line. We have or equal to, so it's going to be a solid line. And we're going to be shading on this side. So I'm not going to do all my shading yet. I'm just going to put a little indicator of I need to be shading on one side or the other side. Okay, for the next one, I'm doing green. Y value is greater than or equal to 0. That's this horizontal line going along the x-axis. We're going to be shading above that. Y value is greater than that one. Okay, for the next one, the third equation, y value is less than 3x minus 2. So I'm going to put a y-intercept here at negative 2. We got a slope of 3, so I'm going to go up 3 over 1. This is less than, so it's going to be a dashed line. Something along those, or along that way. And it says y value is less than that, so I'm going to be shading this way. And the last one, do in black pen, we have y value is greater than or equal to a negative x plus 4. So I go up to 4 and got a slope of negative 1. And it's a solid line. So okay, it says y value is greater than that, so I'm going to be shading above this one. Okay, Our solution region, we have to be above the x-axis. We are shading above the black line. We are shading on this side of the blue line. And, you know, we were shading on the right side of the red line, but that's already taken into account with these other lines. So this is our shaded region. This is where the solution to this system is. And so just as an example of a solution, if I pick this ordered pair right here, 5, 4, that will satisfy all these equations. Okay, if I plug in 5 for x, 5 is greater than or equal to 0. Yes. The y value, 4, is greater than or equal to 0. Yes, it is. If I have 4 less than 3 times the x value minus 2, 15 minus 2 is 13, that's greater than 4. Yes. And the last equation, 4 greater than or equal to a negative 5 plus 4. 4 is greater than or equal to a negative 1. Yes, it is. Okay. So this point, which is in the completely shaded region here, it satisfies all the equations. That's the whole idea. It's a solution to the system. All right. So to graph each inequality in the coordinate plane, this one looks a little bit different. It's really similar, but it does behave a little bit different. It's called a double inequality. We're going to look at it as two things: x values greater than or equal to negative 4, and we're going to look at it as x values less than or equal to negative 1. So we're separating this double inequality into individual inequalities. Now, there is this and statement in between. Okay, double inequalities, you got to have them both. So x values greater than or equal to negative 4. Vertical line going through x is negative 4. We're going to be shading greater than that, so on the right side of it. For the x values less than or equal to negative 1, again, I put a dash line there. That should not be dashed. Solid. For x values less than or equal to negative 1, again, solid line going through negative 1. And x values less than that, so we're shading on this side. So our solution, we got to be having both of these things satisfied, where we're shading on the right of the green line and on the left of the blue line. So our solution region is anything in between, and that's it. Okay, to write the system of inequalities, these are just a bunch of lines. So it's kind of hard to tell here, but the shading is, you really can't see the green line or the black line. Here we go, the blue line. The shading is in this space. All right, so the easy equations. We're shading above the x-axis. That's y values greater than or equal to 0, and it is a solid line there. We are shading on the right side of the y-axis. That's x values greater than or equal to 0. Now, we have this line right here. We'll call it line L. We need its equation. We are shading below it, but we need the equation for it first. So we got a y-intercept there at 5. So mx plus b, I'm just going to put this plus 5. It goes up to this point. So as far as the slope, we're going up 1 over 4. That's the slope of 1/4. So 1/4 x plus 5. We are shading below that line. And it is a solid line. So y values less than or equal to. And now we need this line down here. We'll call it line M. I don't know what its y-intercept is. We have a couple of points. The point E and point F. So we need to get its slope. Difference in the y values, 6 minus 0 over difference in x's, 4 minus 6. 6 over negative 2 is a negative 3. So we're going to have y values. I'm holding off on the inequality sign, but negative 3x. And I don't know the y-intercept. It looks like it's going to be positive. So to get this, y, I'm just going to pretend it's equal for now. Y equals a negative 3x plus b. Back from chapter 1. Choose one of your 2 points, plug it in for x and for y. I'm going to go with point F. The y value is 0, negative x, oops, negative 3 times the x value of 6 plus b. So negative 18 plus b equals 0. B has to be a positive 18. There's our y-intercept. Now, we are shading below this line, and it is a solid line. So y value is less than or equal to. There's our system of inequalities that is graphed here. And we'll do this warm-up in class tomorrow. Have a good night.